Hello everyone. In today's video, I'll be talking about electron ionization mystery and why scientists use 70 electrovolt in GC electron ionization. What if I told you that to identify a molecule, scientists first have to destroy it? That's right. In one of the most widely used analytical techniques in the world, used in crime labs, drug testing, food safety, and environmental monitoring, we literally blast molecules apart with high energy electrons. And here's the really weird part. We've been using the exact same energy level, that is 17 electron volts, since 1952. Why? Is it magic? Is it tradition? Or is there actually science behind it? Hi, I'm Simona, and today we are diving into the fascinating world of electron ionization. The hard ionization method that's been the workhorse of mass spectrometry for over 70 years. Let's find out why breaking molecules is actually the key to identifying them. So, what is electron ionization? Electron ionization, or EI for short, happens inside a mass spectrometer, specifically in a component called the ion source. So here's how it works. Step 1. A tiny tungsten wire called filament gets heated over 2000 degrees Celsius. This causes the electrons to boil off the filament. These electrons are then accelerated by applying a high voltage, typically 70 electron volts. In step 3, your molecule which just came from the gas chromatograph floats into the chamber as a gas. Bam! The high energy electron crashes into your molecule, knocking out one of its electrons. This creates what's called a molecular ion. Your molecule, but now with a positive charge. We write it as M plus E gives you M plus 2E minus. But here's where it gets interesting. This molecular ion, it's usually unstable. It's like a vase that just got hit with a baseball. It's got so much excess energy that it can't stay in one place. So it fragments. It breaks apart into smaller pieces, each with its own mass. And this is actually called electron ionization. Look at this. This is called a mass spectrum. Each peak represents a different fragment of the original molecule. It's like a unique fingerprint. And here's the crucial part. The same molecule will always break apart in the same way, creating the same pattern of fragments. This means we can compare this pattern to a library of unknown patterns and identify unknown compounds. Okay, now for the big question. Why 70 electrovolt is used? Why not 50 or 100 or any other number? Let's look at what happens at different energies. If the electron volt that is applied is below 10, it is not enough energy. Most molecules won't ionize at all. Nothing happens. So around 70 electrovolt, we hit the sweet spot. This is where ion intensity is at its maximum for most organic compound. You get the most signal and the best sensitivity. And if it is above 70 electrovolt, the intensity keeps on going up slightly. So why don't we use 100 electrovolt or higher? Now, if 70 electrovolt is used, there is lots of fragmentation, tons of structural information, great for identification. If we use lower energy, that is around 14 electrovolt, much less fragmentation happens. You can see the molecular ion clearly, but you won't get fragmentation. So, in low energy, we see the molecular ion but lose structural information. And at high energy, we get the detailed fragment but lose the molecular ion. So you can say 70 electrovolt is the Goldilocks zone. It provides maximum ionization efficiency for most compounds, rich fragmentation patterns for identification, reproducible spectra that can be compared across different labs and instruments worldwide, standardization. Since 1952, millions of reference spectra have been collected at 70 electrovolt. So this isn't just academic. Electron ionization at 70 electrovolt is used every single day for forensics, identifying drugs, explosives, arson accelerants. That 70 electrovolt spectrum might help us solve a murder case. At security, airport scanners detecting trace explosive use this extract principle. Food safety, finding pesticide residues in your vegetable. The document mentions analysis of 418 pesticides simultaneously. Environmental monitoring, detecting toxic pollutants, dioxins in food, PCBs in water. Drug development, analyzing pharmaceutical purity and identifying impurities. We are talking about billions of analyses performed worldwide every year, all using this 70 electrovolt standard established 7 decades ago. Now let's talk about the limitation and alternatives. Now, electron ionization isn't perfect. It is a hard ionization method and it is too destructive. We lose our molecular ion in hard ionization. For large molecules like proteins, polymers, or really delicate compounds, 70 electrovolt is too destructive. You get so many fragments that you lose the molecular ion entirely. You can't tell what the original molecule was. That's why scientists develop softer ionization techniques. Now, soft ionization methods include chemical ionization. So, what is the difference between electron and chemical ionization? The energy used in electron ionization is 70 electrovolt, while in chemical ionization it is low. The mechanism is in electron ionization it is direct electron bombardment, but in chemical ionization, ion molecule reaction with a reagent gas, example methane and isobutane, involves. In fragmentation, it is extensive, it is hard, but in chemical ionization, it is minimal. And there is absence of molecular ion due to much fragmentation in electron ionization. But in chemical ionization, we get the molecular ion and we can see the parent molecule. The primary use of electron ionization is in structural identification, rich fragmentation process. And in chemical ionization is used to identify the molecular weight. So there you have it. The 70 electrovolt mystery is solved. So what are the key takeaways? Electron ionization works by bombarding molecules with high energy electrons, causing them to fragment into unique patterns. The 70 electrovolt is the magic number because it maximizes ionization while providing rich, reproducible fragmentation patterns. And this destruction technique is actually incredibly powerful. It's the foundation for identifying unknown chemicals in crime labs, food testing, and environmental monitoring worldwide. What I found the most amazing is how this technique developed in 1940s and standardized in 1952 is still the gold standard today. That's the power of good science. If you found this video fascinating, you're going to love my next video where I'll explain how the mass analyzer actually separates all those fragments by their mass. We are talking about ions flying through vacuum chambers at ridiculous speed. Hit that subscribe button and ring the bell so you don't miss it. Drop a comment below. What other analytical chemistry mysteries should I tackle next? Thanks for watching, and remember, sometimes you have to break things apart to truly understand them.